I'm sick that night.
My dad was like, no.
It reminds me of the thing that when they do the stretching over the intercom, it reminds me of that book, 1984 or whatever.
Oh, yeah.
Where they have to do it in front of the TV.
Yeah.
Oh, I hate this stupid light.
Okay, so our directions here say to graph the function, identify the domain and the range. So this one problem actually has 3 answers to it. We got to have a graph of it, and then we got to tell what the domain and the range are. Just a little reminder, you know, but a little reminder, domain is your x's. It's what it does horizontally. So does it go forever both ways? Does it only start here and go? Whatever. Range is your y's. It's up and down. So we're going to have a graph. We're going to tell the domain, and we're going to tell the range. All right, if I wanted to do this without a calculator, it's doable. It's not my friendliest thing because it's got, number 1, a fraction involved. Number 2, it's got a radical involved. So it is going to be a little bit more complicated, but you would be looking at making an XY input output table. Smart word do this in there. First off, I know that I'm not going to be able to graph anything if what's underneath there becomes negative, because that's an I. We don't know how to graph in the imaginary world. So I don't want to plug any negative x's in, do I? I can't have a negative x. It won't show up on my real graph. It would be in the imaginary graph. So I'm multiplying by a third, and so I'm wanting to do multiples of 3 in my head because I'm trying to keep whole numbers, but then it's also got to be a perfect square. So I'm really kind of limited on that. If I did 9, if I plugged a 9 in, no, that won't work because that's 3. If I plug 8, 27 would be it. Okay, what David's talking about is right. If I did 1/3 times 27, that's 9. The square root of 9 is 3. So that would mean I would have to count over here 27 spaces. Okay, so yeah. So I'm not wanting to do a whole lot of that. So that's why, and that's what Abby's reminding me of. That's why I told you that when I have to do something like this, this is what I normally do, give in and go to the calculator. Would it be possible to get some decimal equivalents on that so I wouldn't have to count over here to 27? But if I get decimals on that, that means I used my calculator, right? Because like if I plugged a 1 in here, what's the square root of 1/3? I don't know. I would do it on my calculator. So if I'm going to do that on my calculator, then why not just do the whole graph on there? See where we're going on that? All right, so grab you one and we'll make sure we can type all this in good. I'm going to go to y equals, this f of x here is the same as y. Remember in that whole front top row right underneath the screen, those are your graphing buttons. Anything graphing happens up underneath there. So we're going to hit y equals. Alright, it's got to get a square root on there. Where's it at? Over there on the x squared, see it on the far left? Had to hit second square root. Now underneath that square root I need a fraction. How do I do that? Alpha y equals, enter, 1/3. And then move the error over, but don't move it out from underneath the radical because that x is still underneath the radical. Okay, so don't move it all the way out. And that's stuff you'll have to pay attention to. Does the x go underneath or does it go out to the side? All right, to get an x, right below the mode button where it says xt theta, hit that. And then hit graph. Now, tell me if you need me to send help. The X is right there. Don't push second though. Yes. Yes. Hit graph. Anybody else need me to send help? Gotcha. Yeah. So now to get the fraction bar like that, you push alpha and y equals. Anybody else need help?
I need help with my law.
I can do calculator.
I don't need help.
that 0 with the thing through it, that's called theta, and that is the symbol used in trig. I don't know why trig decided it needed its own symbol. Like we use x's mostly in here, trig uses theta. It all just means any variable. I don't know how you get it to show up as that on there instead of the x. I don't know. Just the variable that they choose to use. So anytime you see that, that's just a variable and it's got trig. Alright. Now, whoops, no, it's back on. Now you get something, doesn't look like a whole lot. You'll get something that looks similar to that?
Like step.
Yeah. Well, it's not really steps, but that's how it goes. You know how to look at your table? Second graph, it says table. So I could fill in some points over here if I needed to. 0, 0, that one was obvious. 3, 1. Oh, David, we should have thought of that one. 1/3 times 3 is 1. The square root of 1 is 1. That was silly. I feel a little goofy now.
12 and 2.
Yeah, 12 would have been off my thing though. 1, 2, 3. Hey, I did pretty good drawing that. 3, 1. Look at there. I couldn't do that again if I tried. Alright, so we get some points on that. Now, domain and range. That was the other thing that I asked you about. Domain is x's, it's left to right. This thing is going to keep going to the right forever. I mean, we could go to 27 like we talked about. It's going to keep going to the right forever. But it's not going to go to the left forever. If I get over here in the negatives, that's going to make that be imaginary. We talked about that. So I would say my domain goes from, need to erase that, goes from 0, right, to infinity. I'm honestly confused right now on what class does what. So I'm trying. I don't know if we've used brackets and parentheses in here or not.
Yes, we have.
Okay, good. I get confused because when I in Algebra 3, it's the other class that I mess with, and the purpose about the 3 is to make sure that people get ready for college algebra. So I try to show them all the different ways that different teachers could do it, and I get confused on which class I've shown what to. The bracket means it can touch it. It touches 0. We had 0, 0. The parentheses means it doesn't touch it. You can't touch infinity. It keeps going.
So does the parentheses always go with infinity?
Infinity always has parentheses, yes.
And then the number has parentheses?
If it touches the number.
Does 0 have
Because it could be like, it could be just past 0. Like, you know, after 0 it starts. That would have a parenthesis.
How would we know because the bracket is
On your table, on your calculator, if it did not touch 0 there, it would say error.
okay. So will it always be 0?
So if you go back to your table, if you still got that on there. If you go into the negative x's,
It says error. Like, oh.
Yep. Yep. So if I wanted to be able, this is my answer for domain, but to answer the questions y'all are having, if I wanted to be able to use a parentheses here, it can't touch -1, and then it goes forever. So that'd be the same thing. After -1 comes 0, right? As far as whole numbers go, we're missing those decimals. Ah, range goes up forever. True. So it's going to be infinity again. Oh, the marker doesn't.
Is it 0 to infinity?
The smallest always goes first, and 0 is smaller than infinity. Is that mine?
Yes.
Just go look and see who it says, because my grandma's an ICU.
Oh no, it's like a 866
Okay.
over.
That's the only reason I had it still on back there. Up forever, but it doesn't go below here. So it's going to be the same thing again, isn't it? 0.
Yeah.
So infinity decline. My bad. That's okay. We'll put it on maybe.
Yeah.
It's on my race for a long time.
So will it normally be roughly 0?
Normally,
And
yes.
then infinity?
If it was going the other way, it'd be negative infinity.
Yes, good. goes to the left, be negative infinity. It goes down, it'd be negative infinity. Good. All right, let's try another.
I looked up that word. Well, I understand it.
The removal of little pleasant I would think you just do the whole blood. You're in charge of them, so somebody
Like the 40 things.
Yeah.
I bet some kid from Germany.
Germany. Oh, okay.
I would have corrected myself for German. He can send me on Twitter. I bet a guy from Germany.
Alright, this one says g of x is equal to negative 2 times the cube root of x. The directions are the same. We're going to graph, we're going to give the domain, and we're going to give the range. Okay, I'm going to give you a second, see if you can come up with something on your own on that one. Yeah, you can use them. I told you I would use it, so.
Oh, I didn't mean to do that.
You just sounded so cool.
That's what I asked her. I don't know if I did anything. I was asking. Oh, this one was cool. I like this one. I write down some numbers.
I think that's it. Okay, this one, I don't have as big of a problem graphing this one without a calculator because I know a couple of perfect cubes. Oh, I forget now that I can't slam it like I used to. I shouldn't have started writing. 1's a perfect cube and 8's a perfect cube. 0's perfect cube. So it's not a big deal to graph this one by hand. If you go to your table, mine are out of order because I wrote them as I thought about them. But if you go to your table, you should see 1 goes with negative 2. Negative 1 goes with 2. So I'm going to plot those real quick. I got to count on every line to get the 8s, but I can do that. Over 1, down 2, left 1, up 2, 0, 0, 8, 2, 2, 4, 6, 8, negative 4, negative 8, 2, 4, 6, 8, 4. Okay. When I connect those, am I similar to your picture yet?
Yes, ma'am.
Okay, this is going to come. This is so much easier to connect on here than it is on the marker thing. Alright, domain's pretty obvious. X's, does it ever stop anywhere? X's keeps going forever to the left, which is negative infinity. Good, Kylie. And it keeps going forever to the right, which is positive infinity. So, doesn't like jumping back and forth between methods. Negative infinity to infinity. What about the range on that? Okay. Yeah. Some people have a hard time seeing that it does keep stretching up and down. It doesn't really, my drawing looks like it levels out here, but if it doesn't really, it does keep getting a little lower and a little higher. Now, put on, and this is what Courtney was saying here, the positive infinity happens on the left, but still negative infinity is smaller. So I'll put them always smallest to greatest.
So they're always going to be like that if you have negative and positive.
Negative.
Please forgive the interruption. FBI members that have blood donor sheets to turn in for the blood drive, please bring those to Mrs. Blount's room by the end of the day. Thank you.
I liked it when I didn't get those.
I was just about to say, it sounds so weird, literally.
Alright, now you can write that a different way. What if I told you the domain was all real numbers? Does that mean the same thing as negative infinity to infinity? Yep. So you could also write all real numbers. Y'all have told me before, I didn't know it. Good. And Alex, the foreign exchange student from Switzerland, reminded me that yesterday in Algebra 3, that all real numbers is like a capital R with 2 bars. So
Wait, that's just for a domain, right? That's
the
for
range would also be all real numbers. Cool.
I think the infinity signs are not from your
Yeah, for harmonic
It's like I'm trying to draw a sideways 8 and I can't do it.
Try to do this
Well, I did.
You asked, I said yes. What more do you need?
She told you what you wanted to hear.
Yeah, it was a lot. You just logged
Well, sometimes when people ask me if I miss someone, I say, yeah, just like I miss a sore toe. So I didn't say that.
It's like a minute.
Okay, look at these two. Got a kid, Kyla.
Yeah, it's my favorite stuff.
Just say what I want to hear. All right, we got 2 functions on this one. The first one says f of x equals the square root of x. The second one says g of x equals the square root of x plus 1 plus 8. All of the graphs that we've done so far this year, when we did the absolute values, when we did the parabolas, we talked about how they moved and scooted and flipped and all that from their parent function. Same thing on this. My parent function there is that first one, f of x equals the square root of x. We're going to graph both of them. We're going to look and see how they changed, and then we're going to see if we could have figured that out just by looking at the equation. And if you remember anything about the parabolas and absolute values, you already know how it changes. You can look at that equation and know. That's part of it.
I don't know.
Yeah.
Would it be F1?
That's
Oh,
it.
I didn't know if it was the same difference.
Alright, so first one, f of x equals the square root of x. Let's do that one first. I can do some perfect squares real quick. 1, 1, plug a 4 in and get a 2, plug a 9 in and get a 3, right? 0, 0. And you can plug that in your calculator, that's fine. 2, 4, 2. 2, 4, 6, 8, 9, 2. I always say, and I can't, I'm going to just draw it up there. I always say, this is just my dumb way of thinking things. A square root graph is half of a parabola. Right? Because wouldn't the other half of the parabola be right there?
Oh,
Yeah, so that's my way of thinking. Alright, so pretty good on that one. Okay. The other one, everybody, y'all probably already got both of them, don't you? No. You can plug them in the same, like do them and, put Y1, put the first one, Y2, put the second one. Alright, let's see, to get perfect square, 0 will work. Square root of 1 is 1 plus 8 is 9.
Negative 1 and 8.
Negative 1 plus 1 is 0. 0 plus 8 is 8. If you get a 4, if
how
I
are
get
you
a
doing this in your head wrong?
A 3 and a 2. Yeah, 3 and 2.
3 plus 1 is 4. Square root of 4 is 2.
Oh,
2 plus 8 is 10.
8 and 11.
8 plus 1 is 9. Square root of 9 is 3. 3 plus 8 is 11. So. Alright. Well, Kylie wanted to know how I was doing, so I'll say them. Okay, that 8, 11 is going to be a little bit off. I think mine goes to 10s. But over 0 up 9, 2, 4, 6, 8, 9, negative 1, 8, 3, 2, 3, 10, 2, 4, 6, 8, 10, 8, 2, 2, 4, 6, 8. That ain't right. 2, 4, 6, 8. That is 8. 2, 4, 6, 8, 10, and 11. Okay. So here's our parent function. We scooted it to that one. So what Macy said is correct. My transformation would be up 8 units and left 1 unit. Now, couple of ways you could do that. You could figure that out. Look, compare the points. Okay, here was like, this is a mathematical term, this is contract's another term. Here was where this one started. Here was where that one started. So get to from this one to that one, I had to go up 2, 4, 6, 8, and I had to go left 1. Which is what y'all said. Okay, so that's one way you can do it. Otherwise, just by the stuff that we've already learned about, looking at our other graphs. Whatever's stuck on the end, plus or minus, that's your up or down. So plus 8 was up 8. Whatever is in with the X is the opposite way. Opposite of plus 1 is left 1.
Can you just read it like that instead of writing out all the stuff?
It's a snap. Sydney's like,
Look like they don't know.
Yeah, like people that
Sydney,
don't-
Bradshaw, and Leah Lynch want to know what period I had you. And I said right now. And they were like, well, wait. But then they left. So I was kind of worried they were going to like attack you or something.
You say Leah said that?
Uh-huh.
Leah is
She's a funny
she's
cat.
something else.
They're both funny cats.
You should hear her in her solar room. She says some things that crack you up in her solar jumps on this.
She doesn't say bad things.
She's probably scared of me.
No, she's not scared of them. She just doesn't say stupid stuff. Alright, I'm going to let you try. Yeah. Come on. First one I've got, you can use your calculator, it's fine. First one, parent function says f of x is equal to the cube root of x. And this one says g of x is equal to the cube root of x plus 4 minus 5. All right, I want you to graph them both, and then I want you to tell me what happened to get from F to G. Go.
Mason says he hears wrong way.
Maybe we can draft them on paper.
Yeah.
Very good.
Bless you. No, I'm just grabbing it without right now. That's cool. That's funny, I got them all plotted for both of them, but I didn't connect. So, let's connect that one in black, that was my first one. Almost did that one. Let's get you a different square, I used to work this and make it look bigger. Do that like giant size ones. I'm done. Just a third on that one. Alright, did I get something similar? At least,
Yeah.
did my points match up with your table? Did I check those? Did I do all those right? Okay. To get from the black one to the blue one. Down 5. How'd you do? Okay, all right on that? If you're graphing them on your calculator, and I don't have any problem with that, I told you that when we started. A lot of them, it's easier just to do that. You need to know how to go to your table and get some points, because you're going to have to reproduce this. You know, you can't just have the picture of the screen and say, well, I graphed it. You're going to need to go and pick a couple of points and plot them and connect them. Okay? Can you handle that? It's pretty easy. Everybody okay on that? All right, well, we're going to go from here. The graphing of them was important, but it's kind of stuck in the middle. What we go from here is solving equations with what we've done the last couple of days with all the roots and radicals. We've simplified, we've had expressions. Now we're going to have equal signs in there, and we've got to actually solve. So that's where we're headed tomorrow. 2 thumbs up.
How many copies? What?